This is the Kratom Science Journal Club with Dr. Jonathan Cachet, neuroscientist and expert in psychopharmacology. In each episode, we discuss an article in a peer-reviewed journal. I'm your host, Brian Gallagher, blog and social media writer for kratomscience.com, your source for all things kratom. Happy Thanksgiving 2020. You might have consumed more alcohol than you usually do this year, and it might be your New Year's resolution to cut that out. The holidays are coming, but today we're going to look at a study that shows that kratom reduces alcohol consumption in drunken mice. We hear about people using kratom for opioid cessation, but a lot of people are using it for alcohol as well, including myself, and it actually works. I'm finding it cuts down on cravings, and it helps if you want to stop too. If you want to stop and you're getting a craving, and having some kratom actually takes it away. It's pretty amazing, and that's kind of what this study's about. Another amazing thing is if people aren't even trying and they find that they don't want to drink anymore. This guy interviewed Joe Turner. I interviewed him. Probably might have been 2018. It was one of my earlier ones, but he said, I'm going to read what he said. He started to take kratom. He was in manual labor. He was like a migrant farmer and doing construction work and stuff like that his whole life, and he's in his 40s now, and his body started to hurt, so he got into opioids, and then he got sick of that. He found kratom. So this is what he says. After about a month of using kratom, I noticed that I was slowly losing my taste for alcohol. I would still come home from work and, out of habit, grab a beer from the fridge, but it seemed each night I'd drink less and less until I was pouring out full beers hours later. I just lost all desire for alcohol and any other substances. It was totally unexpected and unintentional. I never thought I'd be the type of person to turn down a Jack and Coke or a pain pill. It just happened. I can't stand the taste of it now, and I enjoy my new sober mental state too much to take any other drugs.
Nice.
Yeah, so that's kind of my experience. Last year I did like a sober month, and I just took kratom about 5 days a week. Then when my month was over, I said, okay, I'm going to have a glass of wine, and I was like, this doesn't feel as good as it used to. So I'm not sure what's going on there, but maybe we can find out from this study. It might just be kind of like a method of administration thing. There might be something with the opioid receptors going on. So the title of the article is G-protein bias kratom-alkaloids and synthetic carfentanil-amide opioids as potential treatments for alcohol use disorder. And this is a team from mostly Purdue University, published October 2019 by British Pharmacological Society. I guess my first question is, from the title, what is carfentanil?
Carfentanil is an analog of fentanyl. And so these are pretty potent opiate receptor binding molecules, more or less. So they're essentially saying, like, is kratom or the alkaloids in kratom better than these other pretty significantly strongly binding opiate molecules? Like, it's binding to the opiate receptor seem to be a way to reduce alcohol use or alcohol consumption.
Yeah, and it looks like in this study they were looking at 3 opioid receptors.
Mu, delta, kappa.
Yeah. And the mu is the one that we're always talking about, that 7-hydroxy and mitragynine bind to. But they were looking at different ones. So this is a mouse study again. They gave the mice 2 different amounts of alcohol. The one was a 10% ethanol drink, and the other was 20%. So when they say 10% ethanol given ethyl alcohol given to mice, is that like the same as a 10% glass of white wine?
I think so. I think
Yeah.
that'd be fair to say.
Yeah. The one they labeled moderate drinking, and the other one they labeled binge drinking, which was moderate was the 10% and binge was the 20%, which would be stronger than wine but not as strong as liquor.
That, yeah, and the consumption schedule was different.
And they also isolated 4 alkaloids in kratom. So last time we talked about speciophyllene or speciophyllene.
There you go.
But so they isolated the 2 famous ones, MG and 7O, but they also isolated painanthine, and I do have I found the pronunciation dictionary, and it also had a speciophyllene that was different than my official kratom science pronunciation.
Painanthine.
Painanthine. And the other speciogenine is not the same as the one we were talking about last time.
Speciogenine.
Right. I don't know if that counts. That just sounds like a synthesized voice saying it, based on what the letters are. I don't know if that's
But these are actually mitragynine is the most abundant, and then these 2 that I just mentioned, P and S, are the second and third most abundant. But 7-O's the 4th most abundant alkaloid, but it's the most potent.
It was interesting, essentially the long and the short of this paper was that there's been reports that people are using kratom to reduce alcohol consumption. Let's see if we can replicate that using kratom extracts. So they got some plant leafy material, and then they made 2 separate extracts and tested its effects on alcohol consumption. Then they looked at these isolated alkaloids, like just in and of themselves, not an extract from the plant material, to reduce alcohol consumption. And then they looked at these other, opiate receptor agonists, the carfentanil, and their effect on reducing alcohol consumption. And so, really it's just a whole series of repeating the same similar type of experiments. And it's pretty interesting, what they find, but that's what they were setting out to doing, at least.
2.4 or 2.5, they explain the what they do, cell culture and bias signaling assays, and 2.5 calculation of bias factors. So what are they doing there?
So the cell signaling assays are actually pretty interesting in that you can take a cell line and transfect it with basically a viral load that will lead to the incorporation of these opiate receptors in the cell wall. And then they'll look at, it's basically tagged with a fluorescent protein. And when the receptor is bound, this tagging link, and I forget what they get, maybe it was Pathfinder or Path Hunter, but it's just a fluorescent protein they tag it with. And then when it's activated, that fluorescence starts glowing. And so they can see to what extent something is binding to those receptors and initiating that signaling cascade by just then exposing the cell that's been transfected with the ligand or the molecule that they're trying to see if it stimulates. I'm sure there's probably a better answer, a clearer answer that we could get from some cell culture guys. But from what I could see, this transfection and the recruitment assays, so basically, after it binds, does it lead to C-amp inhibition, or does it lead to beta arrest and recruitment? They can tell that because it's been a transfected cell that's been tagged with this fluorescent protein.
Yeah, and I should say, just in general, what they're doing is they're giving these mice alcohol, just in general, and they're going to give them kratom, isolated alkaloids, to see how much they reduce their alcohol intake, which in all cases they did.
And that was after this. So the cell, I just want to make sure that we're clear that the cell signaling assays are separate from the behavioral assays. It's a different thing. But what you're saying is right. That's just the behavioral part. At first, I think they wanted to verify that the kratom alkaloid didn't result in the beta arrestin 2 recruitment, which is something we've talked about many times now at this point about how that relates to tolerance. So they just wanted to sort of verify that.
And the mice they use are a strain of mice known readily to consume alcohol. So
and C57BL6 are pretty standard just in terms of behavioral mice experiments. So they're about as normal as it gets. But yes, they can be. And it looks like there is another one here. Yeah, C57BL6N HSD. That strain known to readily consume alcohol. Yeah, so they have the C57 BL6 background, which is just standard, and then they have the BL6N HSD, which are readily known to consume alcohol.
Okay, so they're like Irish mice.
Exactly.
I'm Irish, I could say that. Animal, with the exception of ethanol experiments where mice were individually housed in double grommet cages, animals were grouped, housed in plexiglass and ventilator racks at ambient temperature. We talked about this before as well, but mice used in experiments are kept in cages. Are they more likely to become addicted to substances when they're like that? I'm talking about the like the rat experiment that kind of proved that drug addiction was more about isolation than it is about the actual drugs.
So what you're describing isn't incorrect, but the way you're saying it is I would just modify slightly to say that, like, if given the opportunity to be with other mice, they would rather do that. It's not necessarily like their isolation is causing loneliness and then therefore they're drinking themselves, silly. It's just that if they had the option between being with other mice and drinking a lot or being by themselves and drinking a lot, usually they drink more when they're by themselves.
Okay. I had a couple questions about the next section. It's a 2-bottle choice model of moderate 10% alcohol consumption. Mice were trained to voluntarily consume alcohol in a limited access, 4 hours a day. 2-bottle choice, water versus 10% ethanol. Drinking in the dark protocol during their active phase. Now, what's drinking in the dark?
So we had the cellular signaling recruitment assays. Then we have these behavioral alcohol consumption or alcohol intake studies. And then these next ones, these are conditioned place preference. It's a way to basically assess addiction potential.
Yeah.
And so with the conditioned place preference, do they prefer to go back into the area in which they were given the reinforcing drug or not?
So it's like people go to a bar to drink type of thing.
It's that if the compound you're studying, in this case it's alcohol, is reinforcing or has addiction potential, then the animal will choose to go back to that water bottle or the place where they got that water bottle more often than not. And so the CPP wasn't necessarily to assess whether or not alcohol was reinforcing or not. It was to assess whether or not the kratom-alkaloids were reinforcing or not. And not to sort of jump the gun here a little bit, but they're basically at the end of this saying, well, it does seem like the kratom-alkaloids do reduce alcohol intake and would be effective for reducing alcohol cravings, but there's this liability where they are definitely, have this reinforcing behavior addiction potential, and so our carfentanil ones that don't necessarily have that are a better way to approach curing like alcohol use disorder with opiate-like molecules or the opiate receptors. Using kratom is not without risks, is what they're saying. Compared to morphine, it is less reinforcing or less risky. But then compared to these other selective opiate agonists that they're using, there's less risk. So they're basically just trying to cover their bases and say like, well, we're not saying that the kratom extracts and the opiate alkaloids are not without risk. Maybe there's a better way to take advantage of this system that seems to be reducing alcohol intake with things that are less risky. But it's only in comparison to the other compounds in this paper.
Yeah, that makes sense. It says kratom reduces alcohol intake and locomotor activity in male and female mice. What's the significance of decreased locomotor activity?
A few things when we're looking at the behavioral experiments. And so, yeah, over in, I don't know if we're down here yet, but figure 2 essentially like lays out the behavioral results pretty well with the kratom extracts, right? So on the left with 0 milligrams per kilogram of the kratom extract, we have like our baseline alcohol intake. They give them the 10 milligram per kilogram, and that alcohol intake comes down. And then we give them the 30 milligram per kilogram. That alcohol intake comes down even more, significantly less than what the baseline alcohol intake was. Now, when it comes to measuring the locomotor activity, one could potentially say, oh, well, they're consuming less alcohol because they're not moving, like they're inhibited, they're depressed, like respiratory or like central nervous system is depressed, in that it's not necessarily that they don't want to drink alcohol, it's that they can't move to get there. That would be one potential thing you could say if it decreased significantly. The other thing is that in like anxiolytic states, or like stress reducing or anxiety free states, presumably locomotion would change as well. It says here there was a sex drug interaction for the locomotor activity of kratom, but not for the modulation of moderate alcohol intake or binge alcohol intake. I think it's fair to say this: they're looking at the overall locomotor activity because they want to make sure that like the treatment with the alkaloids, whether they're the kratom extracts, whether they're the kratom alkaloids isolated, or they're the opium molecules, the alkaloids that they're using, that these animals aren't depressed to the point to where like their decrease in alcohol intake wasn't a result of them just being like just numbed out, like just like nodding out in the corner, right?
Yeah.
And so both the extracts had a similar effect on decreasing locomotor activity, but it was only for the first 30 minutes. And interestingly, the alkaloids also reduced locomotor activity, except for I think the P did not decrease locomotor activity. The extracts caused a decrease in locomotion, where the isolated alkaloids M and 5 or 7-hydroxy increased locomotor activity, and the P did not modify locomotion at all.
So would that be like the ideal alkaloid that they might say, oh, this one would be good to reduce alcohol intake because it doesn't do anything to locomotor activity? Would that be the one they would pick as like the safest alkaloid to develop into a drug or something like that?
So, I think without them coming back up to it, ultimately the measures of locomotion are sort of interesting observations, but they're primarily there just to assert that these guys aren't nodding out in the corner, and it's not like alcohol intake was reduced because they're just like half asleep, right?
Yeah.
It was just an interesting observation that both kratom extracts decreased the locomotor activity, whereas isolated M and isolated 7-OH increased locomotor activity, and the P did not change locomotor activity at all. Ultimately, that didn't affect how well they were able to reduce both moderate and binge alcohol intake in both female and male mice. So like overall, kratom as extract and kratom as separate alkaloids all were able to reduce the alcohol intake across the board. But then they go further to say, but because it also induced the conditioned place preference, there is potential risk to using these in an alcohol treatment way, and that we should potentially look at the other opiates that they were looking at overall.
That would be the synthetic carfentanil.
Right.
The significance of like dividing them between male and female, I guess in general, in humans, they say that men have a higher tolerance than women. Is that like a mammalian thing? Does that extend to mice?
Yeah. Well, and so it's a hormonal thing, I would assume. And I actually, give kudos to this study for even looking at the difference there.
Yeah.
If you're just mixing male and female mice together, this effect that we see in that there is a decrease in alcohol intake due to these alkaloids could have just been a wash because it blended between the different sexes. So good on them for actually pulling apart and saying it did it for men, it did it for the women, it did it for binging, and it did it for acute intake. So they saw it across the board. But yeah, that's just a biological difference in consumption of alcohol that is definitely conserved in mice. Of course, there's always outliers. It's not like it's a steadfast rule of physics, but it's generally seen in humans and in mice.
What does alcohol in general just do to the brain?
It's a good question, because for all of our talk about receptors and specific receptor subtypes, and it binds to, receptors heavily in this area of the brain or that area of the brain, what alcohol does is not well characterized, in that there is nothing specifically to characterize about it, because alcohol doesn't bind to a specific receptor or receptor subtype in the nervous system. It basically just makes everything in the nervous system a little loosey-goosey. So like it modifies the way that your neurons send signals back and forth between each other, not because it's actually like binding to this receptor, which causes a decrease in calcium intake and firing rates and this and that. It's because the whole cell wall sort of gets a little bit like separated. Like if you could think about like something being like packed really tight, like if you're like holding a bundle of pens in your hand and they're really pressed real tight against each other, what alcohol does is just sort of like loosen everything up, make everything a little bit more fluid. I mean, there is some involvement of the GABA, the primary inhibitory neuron involved there, but it doesn't bind to GABA specifically, or at least its binding to the GABA receptor doesn't lead specifically to the effects of what alcohol does. Meaning, like, if we pull this receptor out, then the alcohol doesn't have any effect. That's not true. Versus like with the opiates, where if we take the mu opiate receptor out, then we don't see the effects of the drug. So broadly speaking, your nervous system is just like bathed in this alcohol, and the membranes become a little bit more fluid. The control of those signals down the neuronal like axons are a little bit looser, and that is what leads to the effects of alcohol.
Isn't there also something where the sort of frontal lobes are cut off from the animal part of your brain? It stops sending signals to your frontal lobes, and that's why people kind of just turn into an animal when they're really drunk? Is that?
Well, yeah, or essentially the top-down control from your frontal lobes is reduced. So like the effectiveness of your ability to inhibit the like thoughts or top-down control, or like administrative control over your bodily functions and thoughts is just reduced, because that cell signaling is just broadly disrupted.
Just the different opioid receptors. It said we did not observe changes in alcohol intake of 7-hydroxymetragenine compared to vehicle in delta opioid receptor knockout mice. The lack of impact of 7-O on alcohol intake in delta opioid knockout mice, despite increased locomotor activity, suggests that hyperlocomotion alone did not contribute to the observed decrease in alcohol intake.
I'm glad what you just read, that supports what I was saying about just they're using locomotion activity broadly as an indication of whether or not they were like just not moving, right? Whether or not it was actually alcohol or not. So that's good. Look, this is basically saying without that opiate receptor and without the delta opiate receptor, the effects of reducing alcohol intake were not observed, meaning that for some reason binding to that particular opiate receptor seems to be the driving sort of connection or pathway behind how or why these alkaloids reduce alcohol intake.
Yeah, that's interesting. And
it is.
In general, what's the difference between the opioid receptors?
the difference between them is their distribution within the nervous system, and then ultimately that leads to differences in the effects. Here's a really good breakdown. The Mus are found in the spinal cord and then up in the brain, and they're related to pain signaling pathways, euphoria, respiratory depression, constipation. Kappa are found in the spinal cord and have less to do with respiratory depression, and then actually when they're activated can lead to dysphoria rather than euphoria. And delta are typically found deeper in the spinal cord and are more, when they're activated, it's more related to constipation. So basically it's the distribution.
Is there kind of an understanding in this paper? Does it point to an understanding of what kratom exactly does to help to reduce alcohol consumption?
For how well set up this paper was, and honestly, I think we bit off a little bit more than we could chew in that. Once I started reading it, I was like, oh gosh, they're doing male, female. They're doing all of these different, they're doing the cell signaling assays. They're doing behavioral assays. They're doing behavioral assays for addiction, and then they're getting into these different all the different types of alkaloids. Mm-hmm. For all of the stuff that they have done here, they don't have a clear rationale or reason for why activation of the opiate signaling pathways or these opiate receptors actually leads to a reduction in alcohol intake. Just that it does, and that activation and differentiation of different receptors and by different alkaloids leads to like changes in alcohol intake or not changes in alcohol intake. But we're not really there yet as to why.
I pulled up a lot of comments from Kratom Science, and just all of them, when they talk about alcohol, it just says my cravings are going away. My alcohol cravings were lessened. I'm an alcoholic and I haven't felt the need for a drink. I don't want to drink. I don't have any desire to drink. It helps alleviate my desire to drink. It's kind of like just does something to the cravings, and it'd be interesting to find out why. But now I wonder, since alcohol is metabolized in the liver and so is kratom, I'm sure that probably worries some people if, they might want to stay away from taking kratom and alcohol at the same time. And I've also,
we have to talk about a CYP all over again.
Yeah, no, but I've also heard that it's kind of like, and I kind of experienced it once or twice, but I haven't really taken both at the same time that much. But another guy told me it's kind of like he had 2 glasses of wine and it felt like he had 2 bottles of wine, or it's kind of like when you go to Denver and they tell you don't drink as much as you usually do because of the elevation. I think if somebody's just listening to this for kratom and alcohol, they'd probably be curious as to if there's any kind of serious liver threat to taking them both at the same time. I imagine alcohol is going to do the bulk of the damage anyway.
Yeah. And I would say like it's not as bad or known to be or documented as bad as like taking Tylenol and alcohol, right? Taking Tylenol and alcohol can lead to like creations of these metabolic molecules that like literally start destroying liver cells. So, yes. But I mean, saying that is just like saying, French fries are also, parts of French fries are also metabolized in the liver. The liver can handle, multiple things at once. So there is certainly no denying what your experience and the experience of others have been too. But I think I mentioned in the last journal club too, that I would posit that there's something just with the physicality of having your digestive system slowed down, and then that liquid not being able to move through it as fast, that could also be the reason why people don't necessarily want to do them at the same time.
Yeah, that makes sense.
There's been reports of kratom being used to reduce alcohol intake. They did a very thorough analysis of the extracts and the alkaloids, and then the other opiate alkaloids. All of them seem to reduce alcohol intake, except for when we eliminated a few of the opiate receptor subtypes. But broadly speaking, it doesn't get to exactly why this actually occurs, just that it does occur, and that they basically say that we need more research into figuring out why this happens, and that because kratom-alkaloids do show this condition-place preference, there is some, the rewarding properties of kratom present potentially a risk in a clinical setting, and that there are other other opiates that you could use that aren't necessarily as risky, but even in that case, all of the opiates, any binding to the opiate receptors is going to have some sort of rewarding properties. And so I don't necessarily think that they justify sort of, basically setting out to prove that kratom does in fact lead to reductions in alcohol intake. But then they sort of say, but it might be dangerous, so we should probably just skip over that and go right to these other synthetic, opiate molecules. And it seems like a cop-out to me to a certain extent.
Yeah. And another thing is it's a harm reduction type of thing.
Right.
Alcohol is, everybody knows that, alcohol is dangerous and probably causes more destruction than any other drug in this country or anywhere else, really. And so if anybody can reduce their intake, or at least maybe even drink less, maybe if you drink a lot, you have a little kratom, maybe have a beer. That's kind of usually how it happens. It's like, even if I had a couple of beers on the day, that's all I wanted. So it's kind of like with the opioids. It's kind of a harm reduction type of tool, and you're certainly less likely to get in a car accident if you're driving with kratom than with alcohol, or
and if you consume less alcohol too. And I think the person wrote in at the beginning that you had mentioned about how like he just like sort of found himself dumping out more full cans of beer than what he thought he would.
Yeah.
In thinking about that with myself now, like as I have gotten older, it has been like, oh, I'll have a beer, and then you crack it and you maybe have like a couple sips, and then you're like, you just basically don't drink it, and then an hour later you get up to go to bed and you're like, oh shit, I gotta dump this whole beer out. Like it does sort of just happen like that. There's something going on here, but what exactly it is, I don't think that we have a clear indication yet.
Yeah. And see, with me, I never did that until I started on the kratom, because I would, just wake up and drink it the next day warm. I never wasted a drop.
Oh.
See, that's why I had to stop. That's one of the reasons. But yeah, but with the kratom, it's like never not had to deal with cravings until I started to have just a little bit of kratom a couple days a week. It's
wow.
Pretty amazing. It's pretty amazing. And I did it. I feel like if anybody's listening to this and trying to quit too, but I feel like you have to want to quit, and maybe taper down if you're kind of getting the shakes in the morning. Get a case of beer and try to taper down. That's usually what I did, because I was drinking a lot of vodka and liquor every day. And then you pick a day. This is the day I'm going to start, and then I have some kratom that day, and it really does cut that out. Just 2 teaspoons and some tea, and it really does cut down on the cravings. You get them a little bit, but then like after a week, I only get them like once a week now, and it's you have some kratom and you're fine. And it's really pretty remarkable, and I'm looking forward to more of these types of studies so we can find out exactly what's going on.
Well, and you know what I'd say, just broadly speaking, is that the opiate signaling pathways are involved in sort of reward and aversion behaviors, and feelings of euphoria and pleasurability. And so, like, if you were sort of in this state in which you had these cravings to get a pleasurable feeling or a mild buzz or a mild euphoria going on, that having these opiate pathways activated essentially get you there without having to consume the alcohol, right? So I don't think that there is, I think that the answer is broadly sort of that, in that it's not we're not going to find out that like, oh, well, this particular subreceptor subtype in this part of the brain, activation of that just turns off the alcohol cravings. It's not going to be that specific. Like there's not really that much to drill down into, in that we know that the opiate signaling pathways are involved in these feelings of pleasurability and euphoria and dysphoria, and modulating, your internal mood. And I'm one that listens to Armchair Expert Dax Shepard's podcast, and he talks a lot about with his battles with addiction, it's been more or less about controlling his feelings and being able to modulate how the inside of him feels on demand, and to a certain extent, taking any conscious modifying drug is about sort of changing how you feel inside. And so by putting something in there that sort of doesn't leave you feeling empty and gives you a little bit of feeling of reward or at ease, then it's going to take away at least the how much you spend fixated on that feeling to want to modify or get back to a sort of a pleasurable state. You know what I mean?
Yeah, exactly. And it's sort of, there's reasons that everybody becomes addicted to, and it's usually has to do with what we were talking about, like with the rats, like, feeling a disconnection, or, a lot of hardcore heroin addicts were abused as children. But the thing with kratom, with the harm reduction, is you don't have to worry about a lot of the things that a hardcore alcoholic or opioid addict has to worry about while you're working out whatever issues cause the addiction in the first place. So that's kind of the meaning of harm reduction in general, I think. Anyway, it's you can have this, and then kind of it'll give you more room to work on your whatever your issues are that cause the addiction in the first place.
Yeah. Well said. And yeah, you can sort of separate a physiological need for a feeling versus the psychological sort of, motivating factors to get there or to avoid that. I think from a harm reduction standpoint, the fact that I don't know how they could potentially, be saying that these carfentanil-amide opioids are more preferred over the kratom-alkaloids, because if they are analogs of fentanyl, I mean, everybody is well aware of what, how potent and how potentially risky the carfentanil opiates are, which isn't to say that they can't be safely used in a medical setting. They can, and they are. You just get you just have to make sure that you're getting something that is properly dosed in microgram doses rather than milligrams. And so they can safely be used in a clinical setting. For a lot of people, sometimes they want to handle things on their own. And so kratom-alkaloids can be taken much more safely in a therapeutic way outside of a clinical environment, to help people, just explore whether or not, it's something that works for them.
Check out Dr. John on Twitter at jcachet. Check out ccvresearch.com and the Cannabis Museum. Like, subscribe, turn on notifications, and we want to hear from you. Comment on this podcast or tweet to @KratomScience. Happy Thanksgiving, and we're thankful for everyone who listens. The Kratom Science Journal Club is produced by me, Brian Gallagher, for kratomscience.com. Take care.